What's going on, guys? In this video we are going to see an example of method of variation of parameters to solve a non-homogeneous differential equation. And here this is the method. Find a fundamental set of solution y1 y2. That's already given right here. This is our y1 in our question and this is our y2 in the question. And let's look at the next thing. After that, what we had to do is we had to solve the system of equation. We had to create equations like this, and we know the y1 y2, that's what we have to plug right here for the first one, and for the second one we find the derivative of these two and plug it and create this equation. But before we do that, we have to bring this equation into standard form, because if you look at the standard form right here, we have y double prime plus py prime plus qy, but here we have a x square sticking in front, right? So we have to get rid of this one. To get rid of this one, what we can do is we can divide everything by x square. Right, so let's go ahead and do that. If we divide everything by x square, this is going to become y double prime and minus 3y prime over x, and this is going to become 3y over x square, and in the other side of the equation we are going to have 4x power 5. Okay, now this is in standard form. Now let's go ahead and create our equation. Okay, so first we have v1 prime y1 is our x value, this x is our y1, so this is going to be x plus v2 prime and y2 is x cube is equal to 0. Okay, after that the second equation is going to be v1 prime and the derivative of this y1. Here if you take the derivative of this x, that's going to give you 1, and then after that we have v2 prime and then derivative of y2, so this is going to be derivative of this one is going to be 3x square, and we equate this one to the function after the standard equation, that is 4x power 5 in our case, so we equate that one right here. Our main purpose of this equation is to find out v1 and v2, because in the particular solution we have to give the answer v1 times y1, v2 times y2, so we have to solve for v1 and y1, right? Actually v1 and v2, because if we find v1 prime and v2 prime, we can integrate this one to bring the v1 and v2, right? Now we have to solve this one. First let's go ahead and let's see what we can do. Let's do the substitution method. To do the substitution, what we can do is we can rearrange this equation. Substitution. Okay, I'm going to rearrange the first equation. Let's say this is 1, this is 2. I'm going to rearrange the first equation like v1 prime x is equal to negative v2 prime x cube. Okay, after this, to get rid of this x, I divide everything by x. So if you divide both sides by x, that's going to give you v1 prime is equal to negative v2 prime x square. So now we found out the v1 prime. Now after that, what we are going to do is we are going to plug this one in the second equation to solve for v2 prime. Okay, let's continue this one right here. This is our second equation. I substitute sub 1. We solve for this one. Let's say this is 3. Okay, so let's say sub 3 sub 3 in the second equation, and v1 prime we found out that is negative v2 prime x square. So this is going to be negative v2 prime x square, and here we have v2 prime 3x square plus v2 prime 3x square is equal to 4x power 5, and if you add them together, that's going to give you 2x square v2 prime is equal to 4x power 5. Therefore v2 prime is going to be equivalent to 2x cube. Okay, now we found out v2 prime, also we found out v1 prime. Now all we have to do is integrate these two to find out v1 and v2, and if we integrate this v1 prime, that's going to give us, okay, we integrate this one respect to you know, I had to find this one in terms of x, then only I can do the integration. Now to find this one in terms of x, we can substitute this v2 prime here. So this is going to be negative 2x cube times x square, and that's going to give us negative 2x power 5. negative 2x power 5. Now we can do the integration. This is still v1 prime. Okay, now if we do the integration of this one, v1 prime integration, I directly put the value, right? Instead of showing integration, we can directly put the value. So v1 is going to be equal to integration of this one, x power 5, negative 2x power 5, that's going to become x power 6 divided by 6. So negative x power 6 divided by 6, we already have 2 in the top, so 2 cancels with 6, that's going to give us 3. So v1 is going to be equal to negative x power 6 divided by 3. This is our v1. Now let's find out v2. To find out v2, we have to integrate v2 prime, and if you integrate this one, that's going to give you 2x power 4 divided by 4. That's going to be equal to x power 4 divided by 2. Now we found out our v1 and v2. Now we can go ahead and write our particular solution. Now to write that one, I get rid of this part because we need some space. Okay, so I get rid of this part right here. Our particular solution for this differential equation is going to be this pattern: y is equal to v1 times y1 plus v2 times y2. So y is equal to v1 is negative x power 6 divided by 3, negative x power 6 divided by 3 times y1 is this one, x, okay, plus v2 is x power 4 divided by 2 plus, not plus, multiply by 2, y2 is x cube, and if you multiply these two together, that's going to give you negative x power 7 divided by 3, and here we are going to have x power 7 divided by 2, and if you simplify this one, that's going to give you x power 7 divided by 6, and this is our particular solution for this differential equation. Now let's note that one down. This is particular is equal to yp, particular solution, right? Now let's see how we can find general solution. To find general solution, all we have to do is we just add, so we put this particular solution first, x power 7 divided by 6 plus this y1 by y2 values, that is x and x cube, and we add constant in front of that. So this is going to be c1, this is going to be c2, and that's going to be our particular solution for this differential equation. I hope this helps. Actually, this is general solution for this non-homogeneous differential equation. I hope this helps. Thanks for watching.